right. Hi, Claire.
Hi.
I wanted to start with your current position. So tell us about what you do now, and do you consider yourself to be a data scientist?
Yes, I do. My official title right now is founding partner of a company called Summer.ai, and we work with companies on data strategy. And typically that encompasses anything you could put under data science, that ever widening umbrella, as well as some core technologies like machine learning, natural language processing, and working directly on those technologies as well. But our thesis is that every company can ask better questions and find better answers, and data is the transparent path to better understanding business and optimizing it.
Okay, that's great. And we'll come back more and talk more about your current company later. But I want to go back and talk about how you grew up and were you into math? Did you start programming early? Kind of take us through your early childhood and your interests that might have indicated that you'd be doing what you're doing now or not.
Sure. Frankly, the only thing that indicates that I would end up being a data scientist is my mother telling me when I was little, don't worry, there will be some career that you'll have later on that doesn't even exist yet. So don't even get hung up on what you want to be.
That's good
There's
advice.
no, do you want to be a firefighter or do you want to be a teacher? There were none of those questions in the household. It was just, how do you pursue things that are interesting to you? And I'm lucky to have parents that were the kind of people who would help us try and derive how far the sun is from the earth at the dinner table. So I was brought up in a very math and engineering centric household. My parents are both engineers, but I actually hated programming when I was a kid. It was too arduous. And frankly, I felt that way for a very, very long time, even through programming classes that I was taking at Stanford, where I went to undergrad. And I think that becomes a strength over time, but all of the interest that lives in the world, I would say, that has driven me toward data science is a childish wonder of how we better understand the world and how we can not better predict, but better appreciate what might happen in the future.
Yeah, definitely. And I'm finding out through more of these interviews that a lot of people say it's just curiosity driven and problem solving driven.
Yes, absolutely.
So tell me more about your parents, and did you have any other role models that were technical, and what did they start you out doing? You mentioned some calculations, but did they have you working on a computer at home?
Yeah, actually, my parents are kind of funny. My dad had a kind of typical Silicon Valley career path up until he and my mom moved to Alaska, and I grew up in a fishing village there.
Oh,
So
wow.
he had started a tech company here, it went public, and my mother decided that she wanted to live where she grew up. So I grew up in a town of 2,000 people. We were one of the first houses that got the internet. I remember going and digging the ditch that the cable was laid in because the telecom company would not lay cable to our house. So we did that ourselves. And it's really funny. My dad was actually profiled in a 1983 issue of Time as one of the first digital nomads because he was shipping chips that he was programming from the house in Alaska to places all over the world, to Finland, to South Africa, to New York, wherever.
Wow.
And
were you involved in the business at all?
I actually didn't understand what my dad did until a couple of programming classes in college, when we were asked to write a basic interpreter. And I was fighting through this thing, and I called my dad at some point to, probably just to complain about it and see if I could figure some stuff out. And he was like, now you understand what I do. My product is a basic interpreter. So that was exciting to finally understand what my dad did. But they were great role models in helping us derive how things work in the world. It was always really important for them that we understand like how a car works, or take a sledgehammer to an old fax machine and figure out how to build a house. I built a house with my mom. So it all centered on figuring out how things work and building them from the ground up. And I think that is absolutely true of data as well. For companies, the analogy there is, how do you understand the components that go into that company and which of them are contributing to its success or its or opportunities. And I carry that all the way through to my work today.
Yeah, definitely. That sounds awesome. So what made you want to go to Stanford, and what major did you start with there?
I think I started with poli-sci.
Uh-huh.
And again, I went to a really small high school. We had 55 graduating kids in my class, and
Small.
almost no one went to college. It's just not that kind of town. Like you go and you fish a couple months of the year, you work on an oil rig. The jobs in Alaska tend to pay pretty well for those professions. So people go to work right away, and they start families. It's a very different culture from what you'd probably find in San Francisco. And I just didn't have that direction at all. I was very curious about how things worked and wanted to explore as much as I could in my first couple of years at Stanford. And I felt really like I couldn't find the right box to put myself in for a long time. And I think a lot of students have that experience. What major am I going to be? Like, is this too constraining for me? Does this encapsulate my interest? Does this challenge me enough? Mm-hmm. And I had always been deeply interested in linguistics, took linguistics classes. I have taken, I think, 7 different languages over the course of my professional and academic career.
Wow, which ones?
Which languages? So French, German, Spanish. I have studied Turkish, Russian, Latin. Got to be forgetting one. I also speak Alemannic, which is a dialect in the Alps, or a language, depending on your linguistic.
So you can go anywhere in Europe and survive.
Maybe. Probably with my English, though.
Yeah.
Right. So I actually circled a couple different things until I found some classes that really challenged me a lot. And those were in mechanical engineering, computer science, and a program called Management Science and Engineering, which you could say contributes heavily to an umbrella of data science. Mm-hmm. I took a class in that department, which I fondly called Excel-tastic. And in that class, we'd build Markov chains in like Excel macros and try to figure out how many cars we're going to go through, like 2 toll booths and then 3 toll booths, and these kind of silly optimization problems that were really fascinating, but I couldn't figure out why they mattered. Why was that ever going to matter to me? And it's funny to look back at that now, because of course that was the basis for my interest in statistics. And I think we were required to take statistics and computer science. I don't know if I would have taken them if I hadn't been forced to. I went through a really great program called Science, Technology, and Society, which allowed me to go through the mechanical engineering and the computer science tracks for product design within them respectively. And it has a component between it of engineering ethics and responsibility, which is something I focus on to this day. I recently gave a talk about algorithmic bias and responsibility of engineers. So that's something I'm deeply passionate about. But at the time, I focused on product.
Let's talk a little more about that with the ethics background before we get into the data science. So tell me some things that you learned in your curriculum, and then, since then, how have you applied it, and what have you learned about ethics, particularly when in your data science business?
Sure, happy to speak to the undergraduate career, of course. So one of the classes that I took and then ended up teaching was a capstone course for computer science, in which students were asked to consider different ethical quandaries, and I ended up leading a section after I had taken the class myself. I had an interesting interaction with the students that was very enlightening for me.
Oh, yeah?
In one particular class, I asked them a question. Say you're at a large social networking company where people post their own pictures, and your manager asks you to implement an automatic face recognition algorithm. What do you do? And I went around the room. These are all seniors at Stanford, people who already have job offers in hand at all of the big tech companies. Half of them are going to Google. And they just kind of looked at me like, why would I care? Of course I'm going to implement that. It sounds great. It's like machine learning. It's challenging. It'll be recognized in the company. It's great. And I said, okay, so let me give you some more context. At the time, this was right after the Arab Spring. And I said, Iran just jailed, I think it was 50 people that they had found through pictures on Facebook. Do you still want to implement this algorithm? And people said, well, I mean, yeah, that sounds like a bad outcome that might be precipitated by this thing I built, but wouldn't I get fired or something? Or like, if I get fired, they're just going to put someone else on it, right? And that's where I had to stop them, because the resources of engineering are not infinite, and you actually drive up the cost of building that technology by refusing to build it. And so one of the things that I hope for engineers in general is that they can feel, and data scientists as well, that they can feel empowered to take responsibility for these decisions, because they do change the market and they change whether things get built. Technology doesn't want to be built in that sense. There is a social force at play that causes it to be built. So yeah, that's definitely one of the threads that I'm following very closely.
And I wrote a blog post about how you can introduce bias in algorithms. I referenced a lot of the articles online that had already talked about that, but it's kind of a challenge to data scientists to say, look, you do have an impact, and people kind of treat machine learning like, well, it's the machine. I'm putting data in there. It's telling me something. I'm not possibly introducing bias. But, how the data is collected matters, and which field you choose to use or what you remove. So talk a little bit about bias in particular.
Yeah, so another great example of bias is a classifier that was built at a company I worked for called Mattermark. And they were interested in finding how companies were growing and understanding whether they were growing. And in that process, they decided it would be interesting to look at founders of companies and understand who they were, and then look at the broader group of people in the Bay Area and see who would likely become a founder in the next 6 months. So in developing an algorithm that could do that, they did some data exploration to understand what characteristics would contribute to you having a likelihood of being a founder. So these are things like, what school did you go to? Did you major in computer science? Did you have a title of engineer? How long have you been working in industry? How long have you worked at a venture-backed company, if you have? And those all seem like reasonable features to build around this. And I didn't work on this project personally, so I got to look at the results after it was done, and I started paging through it, and there was a list of people, and the people that were ranked at the top were actually ultimately invited to an event by a VC so that they could essentially get pre-crime on people who are going to start companies. It would be great for them to know them before they started their next thing. And on that list, there were about 200 people. And of the first 100, only 13 of them were women. Wow. And only 2 of those women were not Asian. Fascinatingly, it was 1 white woman and 1 black woman. I thought that was particularly interesting. But what's problematic about that algorithm is that it was creating data that was then used in the real world and used to make a decision about who to invite to this event. Right. And what that introduced was a bias that had already existed before into the real world now. So it seems defensible because there is no gender feature, but it's not, because the bias still exists. And when you push that data forward and you use it for purposes in the real world, you end up inflicting that bias back on the real world.
And you're training those algorithms based on data from people that have become founders, which might already be filtered down to, a biased result based on who makes those decisions.
Right. It's not who would potentially start a company. It's who actually got funded, right? So if you consider that, you're literally pattern matching in the way that VCs are often accused of pattern matching.
Right.
It's very problematic.
Wow. So how did you go from, so you mentioned that you taught this class at Stanford also. So what was the rest of your time at Stanford like? And then did you go right into a career from there?
I focused, as I mentioned, I actually focused on product design and engineering through that program. So I was well suited to build lamps, which I did, as well as build software. So I joined a software company, and actually one of the first things I worked on was a timekeeping application for a software company, and started getting really interested in the data around the prototypes I was building, but I was a designer. So I was a front-end engineer as well as the person responsible for some of the visual design, but predominantly the UX design in that product. And that was true of the next couple positions that I had as well. So if you fast forward a little further down the road, I was actually in Germany. I had decided to go experience a different startup environment. I was working for a company there, and I noticed that we had a couple decisions to make about which landing page to show to customers that were trying to understand our product. So I thought, okay, I want to understand who these people are because I haven't seen the logs. I don't know who's actually visiting the website. I went and talked to the head of engineering of the parent company. This was, German companies are weird, and they have like startups inside them sometimes. And the engineering team just kind of shook their heads like, we don't have any logs. We don't log anything.
Really?
And I remember thinking, that's weird. That seems like a really bad practice.
And what year was this?
This was 2013, beginning of
So not long ago.
2012. Not that long ago. The company's also not around. The parent company isn't around either. But I found that I wasn't going to be able to make that decision without that data. And we ended up being shut down as a group. So that converged with my train of thought heading off in a different direction. I ended up writing the data science master's curriculum at that point.
Yeah, so tell me about the origin of that. Like, what inspired you to write the curriculum, and did you have the whole curriculum complete before you started on it?
Yeah, that's a good question too. So I, as I mentioned, had just left this company, and I had also recently spoken with a friend who was working for the New York Times, and she was doing her master's, or had just finished her master's in statistics at Columbia, and had started working with the Times and a couple other companies, and had recommended that I read a couple books, including Nate Silver's book. And I ended up reading it in like 2 days. I was like, this is the most interesting thing I've ever consumed, and became deeply obsessed with it. And I thought, if I'm so interested in this, I should be doing this professionally, because I don't feel that the career path I'm on is very long. UX design is a stunted career path at this point. And people who are in it usually move to product management after some period of time. So
I didn't realize
it was a question of whether I wanted to move to product management or do something else. And given that I had the programming background, it seemed like a reasonable fit. And I thought, okay, I could choose to go back to Stanford. It would take me about 3 years to do a machine learning master's and then get back into industry. But really, I just want to work on products. I've always been a product person. As I mentioned, I've always been interested in how the thing works, taking it apart, putting it back together again. So I drafted the curriculum as a guideline for what I would do going forward. And I think I had really great ambitions, or great in the sense of large ambitions, to solidify it before I started. But the reality of the curriculum was that it needed to evolve as I went through it. And I was the guinea pig for the curriculum, and I have my my own path up there now that the curriculum is forked, so to speak, from what I originally did. It's a standalone thing, but the path I took is all documented in my little curriculum resume.
And how did you decide what to put in and what to leave out?
Mm-hmm. I took a lot of advice from friends. The friend I mentioned, who's a statistician, and data scientist, as well as another friend who has recently become a data scientist, but at the time he was doing a master's in physics and aerospace and teaching linear algebra to PhDs at Stanford. Like he was doing remedial linear algebra for people. And he was like, you really need this at the beginning. So let's just get through the linear algebra and then you can work on everything from there. So he and I ended up Skyping every single day and doing about like 4-hour-a-day sessions for 6 weeks to do linear algebra. And I am forever grateful for that kind of support and my family, my friend group. But that really awakened me to what I needed to understand going forward, and just reading blogs, trying to understand what's actually being used in industry, pursuing some of my other personal interests. As I mentioned, I'm like deeply obsessed with languages and linguistics. So natural language processing has been something that I've invested a lot of time in understanding as well. A lot of the introductory work or the introductory classes that are up on Coursera are really great places to start. So Bill Howe's class was really great. I think I was in the first session that he put online. It just happened to be starting right then. Coursera was undeniably the most valuable thing to me at the time. And people slam it, and people slam video, but I am the kind of person that learns from video, and I love being able to stop it and rewind it. And it's the kind of thing.
It really depends on which course. I mean, you can't just make a blanket statement about Coursera as a whole.
No, you can't. You really can't. That's absolutely right. And I think one of the funny things is I started to realize the true value of my my previous opportunity to study at Stanford, because most of the content that I found on Coursera that was the best was actually from Stanford. And I was trying to be very meritocratic about it and do a full survey to see which classes were the best, and they usually came out on top. I was pretty surprised by that, frankly.
Wow. So tell us about the actual experience of doing this. So, you told us about the resources and how you found them, but what was it like to go through and learn each of these topics?
It was, so people always ask me what was the hardest thing about the masters, and the answer is not like learning recurrent neural nets or like, I don't know, like Bayesian graphical networks or something. I had to product manage myself or project manage myself. And that is the most difficult part of teaching yourself, because you have to sit down every day and apply that rigor. And it takes a lot of
full time.
I was doing it full time. Yeah. And
so what was it like? How did you schedule that? How did you manage that?
Yeah, I got up every morning. At the time I was living with family friends in Austria. So I'd stayed in Europe for a while, and I'd moved from Berlin to there. I was getting up every morning, having breakfast with them at 6. I would sit down and do homework, usually linear algebra at the beginning. From about like 8 to 11, I'd go for a run, I'd make lunch, I'd sit down, do lectures, I'd do dinner, family, and then I'd have Skype calls at night with people that I was learning from, or people I was talking to about what I was doing. It was actually really lonely. Like I saw my family, and I saw my friend who was tutoring me, and I shut out pretty much everything else. And I made a very deliberate decision not to do any like freelancing work or work on any of my side projects. And I think that was one of the harder things to do, but it's extremely, extremely important, because if you multitask and you take any time away from that, you add any switching cost, you don't get as far. So I was very focused on managing that process and making sure that everything I was studying, I was evaluating the value of frequently, so that I could keep myself on the right path. Because you could take a machine learning book and you could spend the next 4 years learning everything, and
Yeah.
still wouldn't have learned everything. So understanding the 80-20 of the payoff of various topics was a huge part of that, just managing the direction and setting course every 10 days, maybe, I rewrote the entire curriculum. It was very arduous.
How did you do that evaluation? What were you evaluating against?
I looked at what people were working on in industry and what kind of problems they were solving. So it's things like reading people's stories about the problems inside of businesses that they had encountered, taking some of the sample problems from classes that I was taking. You know, there are dummy problems like, I don't know, find the connected components of the graph you build from the Twitter stream for the last 5 minutes, that kind of stuff, which is not necessarily business applicable, but does give some constrained direction. I think the hardest thing to do is find a project that is constrained and scoped well enough such that you can actually get it done and not be buried in work or discouraged, but it also demonstrates some skill and holds some meaning. That's a really hard thing to do.
So how did you decide up front how long you were going to spend on this? And, you know, how did you decide when you're, you know, quote unquote done, or at least ready to move on to the next phase?
Let's see. I think I had just enough money left in my savings for 6 months to live for 6 months. So it was do or die. And by the time I got a job, I was down to like, I remember that first paycheck being like coming just in time. So I cut it down to the wire. But by month 4, I had gotten into some of the machine learning and had gotten my feet completely in the statistics. And I actually hadn't worked in Python before that. I'd worked primarily in Java, C++, PHP, a lot of front-end stuff, HTML, CSS, JavaScript. So moving to Python took a lot of time as well, and I studied quite a bit to become more familiar with the workings of Python, which is required if you're going to put anything past the interpreter.
Mm-hmm. So, you know, how did you make that decision that I'm ready? And what was your next step? Did you just start applying for jobs?
Let's see. So I was living in Austria for a while, and then I moved back to San Francisco. And of course, that set the clock really ticking after paying rent here. I remember my dad at some point saying, "Can't you just get a waitress job?" And I did the calculation. It was like, I'd have to have 7 waitress jobs to pay this rent.
Oh man,
that's a lot. I don't think I have that many hours in the day.
That's motivation, though.
It's illustrating. So I started talking to companies, and for the most part, they were not interested. They did not care that I had done my own thing.
And is that just because they're so tied to like the Stanford degree or something like that? You know, is it just their history?
I mean, if they were tied to that, I have one of those. I don't know why that would have changed things, but I think there was, it was just a red flag of sorts for many companies. Like, this person wants to put a stamp of approval on themselves. How is that legitimate? And so part of the reason that I put the open source masters online was so that I could demonstrate what I had done and say, these are the things that I did. You can choose to like not believe me, put me against a test, like give me a challenge, whatever you need to do, but this is what I've done. And I found a couple companies that really recognized that I don't know, hustle, I guess. And I'll just say shortly, like, big companies process a lot of people, so it's really hard for them to, you know, to take a full look at something that doesn't fit the pattern. So I talked to a couple smaller companies and ended up at Mattermark, which had some really, really interesting challenges at the time, and they were looking for their first data hire. And they had started about 6 months prior. The CEO there is a very like data involved, data obsessed person. Does amazing things with Excel sheets. She does program a little bit, but was not she wasn't on the engineering team because she was running the business. So they were looking for their first data hire. And I remember, I'll never forget this, on my first day, they had asked me to sit down with the CTO and talk more about the machine learning that they were trying to do on their their data set at the time, and they were just putting everything into the Google prediction engine, everything they could find, and just scrape it together, just throw all of it in there. And like anyone who's done machine learning understands why this doesn't work. But it was really fun because in 15 minutes we took, I don't know, 4 months of blundering around off of the roadmap and fundamentally changed the way the company was going. And later they said, that the CEO told me that they were planning on divesting in machine learning completely 2 weeks after that. They thought it just wasn't working. But we ended up building a machine learning team there, and they're a great talented group. And they have a data product manager and a data team as well that works on the core data and really invests deeply in that. And I had a great time building those teams there.
So that's pretty inspiring. So this was your first job where you did machine learning. It was their first machine learning hire, and you totally turned around even their impression of what they could get out of it.
Yes, yes.
And what made them hire you? Did you have a portfolio? You know, how did you convince them that when they were on their, you know, last leg, or, you know, what were they looking for that you had?
Yeah, they were actually looking for someone who could do machine learning and was also a generalist, because they were literally in an apartment at the time. When you're 8 people, you need everyone hands on deck. So I was working with data as well as building product. I built a ton of the UI. I built their Google Chrome extension, like some of their first mobile applications. I had done front-end development as well and design, and they were intrigued by that because they didn't have a designer at the time. I ended up later hiring a designer because I don't think I could have handled design and data science all at once. But I had a couple projects that I had completed at the end of the data science master's, very small pet projects that to me today are just like, it could take me 15 minutes, but at the time they were very substantial for me. And I think we generally went through a normal software engineering interview, walked through a couple algorithms, walked through some real world challenges that they had around web scraping, talked about deriving algorithms to build proxies for things like how fast a company is growing based on its employees, or what their run rate cost is based on the number of employees, those types of things. So really fun, applicable challenges to the business at the time.
So if someone else were to follow your data science master's program, and then, you know, what tips do you have for them, either in terms of picking and choosing, you know, which parts to start with or how to move through it, and then developing those kind of projects? Like, what advice do you have for somebody else following it?
I think the biggest challenge is defining that project that you want to showcase your work, because it's, as I mentioned, it's very hard to bite off just enough, not more than you can chew, not less than you can chew. And I've spoken to a couple people since who are working on capstone projects. I've been, you know, informally involved in a number of the academies here and abroad as well. And it's very, very difficult to understand how much you're biting off. So if you can go ask someone, hey, is this the right size of project? Do you think this is worth investing in? And you can just keep searching for the right design of that project, and make sure that it's something that's interesting to you. It doesn't have to be business relevant, but it does have to be interesting enough to you that you're not going to get sick of it. Mm-hmm. And you're not going to get stuck because it's boring. So focus on something that's really interesting. I don't care, baseball. Like, I'm not interested in baseball, but someone might be, and that's okay if it's not business relevant. People ask me where to start in the open source data science masters. Start at the top. Start with an intro class, and you will find the things that really get you excited and the paths that you want to go down. I think that's the great thing about some of those intro classes. They just give you a peek into these different disciplines that make up data science. And ultimately, you probably have to decide whether you want to be a generalist in many ways and a specialist in a very narrow place, or
Mm-hmm.
whether you want to specialize in something that's slightly broader and not generalized. And I've seen both approaches be successful in getting people into industry. And we definitely have hired, I in my career have hired both types of people, and they're both required by businesses. So it just depends on what you're shooting for. If you want to work on, I'll loosely categorize things as like 0 to 1 problems and 1 to N problems.
Mm-hmm.
Most bigger companies that have been working on a solution for a while have 1 to N problems. So you're going to be working on an algorithm that already exists, trying to improve it by a couple percentage points, or maybe even like smaller improvements. And in a company like Mattermark, you're going to get thrown in the deep end. And if you can prove that machine learning works at all, that's everything to the business. And that's going from nothing to something, right? So the generalist persona, or the generalist background is more important when you're going from 0 to 1, and the specialist background is more important from 1 to N. Just keep that in mind in which direction you want to go. Mm-hmm. And talk to people in industry. I think you in particular have done a great job of reaching out to people and just asking them like what they're working on, what they do. And that's the best way to learn about what you're going to need and what you should study now, and what people actually do day to day, because there is this very like sexy image of what people do. And I can beat a dead horse and say I do a lot of data cleaning, but it's important to know what you're getting yourself into.
So going from there, well, let me back up. First, if somebody were to start with the open source data science masters, and they started with a background similar to yours, so they have an undergraduate degree, some technical background, how long would it take to get through the entire thing? And do people need to get through the entire thing? And then should people focus on it full time, or is it something people could do in their spare time?
Sure. So should you go through the whole thing? You absolutely should not go through the whole thing. Mm-hmm. In fact, you should cherry pick. You should be very strict about what you include, because as I mentioned, you could spend your whole life on one of the topics that's under the umbrella. And if you're interested in becoming a generalist, you need to figure out which of those topics is relevant. And then within those topics, what focuses will help you solve problems. And the challenge as someone who's learning is that you may not have seen the types of problems that you will see in your job or in industry. And that's okay. Do a lot of research and try to use your best inference. Like you're going to spend a lot of time using your intuition to solve problems in industry. So this is the first step. Use your intuition to figure out what is the most important part of a discipline. Things like you take a look at networks. Do you really need to understand Bayesian networks? Do you really need to understand how to quantify things in a social network? Which of those is more important to you? Do you know how those apply to different types of problems? Do you know which one is easier to explain to someone that's interviewing you and might be a good case study for you to demonstrate what you've learned? Mm-hmm. Just think about all of those things. I have to say the overhead of figuring out what your own curriculum is really big, and you shouldn't discount it. It's definitely part of the work.
So what percentage of the curriculum do you think you did in that first push, and how long did it take you?
I'd have to take a look at what the curriculum includes now, since it's so different. It's kind of this living document. Mm-hmm. And I try to include just I get pull requests, and many people have contributed to it, but it is the strictest list of the best resource for a given topic for the topics that I believe are important under like Python for data science. So it's certainly one take on the set of things that might be important. I think I ended up doing maybe like half to 2/3 of what is on the full curriculum now. there are certainly things in there that I just don't have any specialization in, and that's okay. I don't necessarily need it. A lot of what goes on, especially in industry, and some people will tell you this and admit it, and some people won't, is just-in-time learning. And you really have to be good at spinning up on a new topic quickly. So part of that generalization is understanding what basis you'll need to then be able to reach the other topics on that branch of the tree. And just having the basic understanding so you can say, yeah, I don't know exactly how that works, but I'm going to figure that out, and I have a basis for understanding how most of that should work, or have an intuition for how to solve that problem. So just having the components in the right place.
And how long did you spend on that?
Spend on the curriculum at large.
When you did that initial first push before, I mean, I know you're continually learning, but how long did you spend on your first, several, I think you said several months you were working on it?
Yeah, 6 months.
6 months. Okay. So 6 months full time, so people can kind of estimate how long that would take them to do part time from their starting point.
Yeah, and part time is really hard because task switching is expensive. It's really
it is, and people always ask me, how do you make time for this kind of thing? And it's pretty much the same as what you said for me. Is like you just have to say no to a lot of stuff and just hunker down and do it. And you're going to give up a lot of social activities, but you have to just have the focus and do just that for a while. It is hard part-time. Yes,
absolutely. It takes a tremendous amount of willpower and focus.
So tell us about what you do now, and tell us about summer.ai and a little more about what kind of projects you've worked on and anything you want to highlight from that.
Yeah, sure. So Summer.ai, as I mentioned, is a data strategy company. So we actually don't focus on implementation, although we do implement some systems. We focus on helping companies ask better questions and then answer those questions in the right way. So for one of our customers, they had a question about how to understand a bunch of customer responses that they were getting, essentially like tens of thousands of emails that they would get every couple days, and they wanted to understand what customers were saying. And they're actually a vendor that would help their customers do this. So we worked with them to understand the scope of the problem, whether it was solvable, and if it was solvable, what products in the market would be useful for them, and what kind of team they would have to build to solve that problem or answer these questions. And ultimately that focused very heavily on NLP. We've seen a lot of demand in the market for understanding natural language and unstructured text. This was also true when I was at Mattermark. One of the things we worked on there, which is something they're working on to this day, extracting facts from text, particularly business news. So you can imagine if you want to assemble all of the business news in the world so that it's searchable and you can filter it kind of like in an Excel table and say, how do I sort by all of the financings that happened today in California with tech companies? And you wanted that Excel sheet. That was the challenge that that company had. So one of the mandates we got was to take that unstructured text and turn it into structured information. And so it's kind of a fancy way of describing indexing to some extent, but it really did require a lot of natural language processing focus. And since there aren't generalized solutions for these types of problems, it's really important to focus within your domain and understand the shape of your problem. So a lot of the work that we do with customers is around figuring out how to shape that type of application for their domain so that they don't throw everything into Google Prediction API or into AWS machine learning, AWS's machine learning platform. So one of the challenges in both in learning data science and doing data science is knowing what you can condense and what you can say no to, what data you actually need and what data is going to be fruitful for you. And that's one of the focuses of this company. Of course, another focus that we get to work on is understanding how data organizations work and data science organizations work, and how data can answer questions for the business. And that sometimes looks like traditional reporting and understanding what KPIs to build for a particular team, and understanding how to manage data scientists and build community. But there are a number of best practices for building data science teams, some of which I've written a little bit about online, that that can be really useful for companies. So there's this rising tide of interest in data science. A lot of companies that haven't been able to make the investment yet and want to understand how important it is to their business, and they need a roadmap to help them understand how much it'll cost for them to go from A to B, and if they end up at B, what kind of business value they'll have when they get there. So,
and do a lot of companies end up having a lot of what they need already, and it's just a matter of training some of your existing analysts, for instance?
Yes, that's absolutely one of the things that we like to focus on. I think it's really important to look at the resources that exist, and you can come into a company and say, hey, you don't have the data that we need, and you need to hire a team, and you need to do all these things to do it the right way. But realistically, in terms of how organizations work, you want to look at the data that exists already, and you want to look at the team that they have and find the best solution for that. And any recommendations you make on top are sugar. But it's important to look at, especially with the focus of this company, the data that exists, and see what you can do with it, because a company's proprietary data is actually one of their greatest values, and they're just very interested in leveraging it.
Yeah, definitely. So tell us how we can find your company and how we can find you online.
Yeah, so we're at summer.ai, which is actually a TLD, and I'm Clare Corthell on Twitter, all one word, and you can find me at datasciencemasters.org as well, which is the data science master's curriculum.
Okay, great. Well, thanks so much for talking with me today, Claire, and I'm sure a lot of people will get a lot out of this interview, and especially out of your master's program. So thanks for putting that together, and thank you for talking to me about it today.
Thank you for inviting me, Renee. This has been great.
All right, bye.